All right, welcome. Welcome to Comp 15. This is data structures. If you are signed up for some other class than data structures, you're certainly welcome to stay, but we're going to talk about some computer science stuff today, so that's that. I am Chris Gregg, and my email is up here. We will talk more about when you should or should not email me a little bit later, but we'll get to that. The call number is up here for the class. Some of you have already done this. If you are on the wait list, there's a sheet up here. You do not need to get it right now if you haven't already. If you're on the wait list, this is what this is for, not just generic like sign up for class. If you're only on the wait list, we'll talk more about the wait list later. But to keep all the surprises, it looks like everybody's going to be let in off the wait list. So if you are on the wait list, you should be let in. And if you've emailed me about other specific reasons why you should be in the class, then that you should probably be in as well. If you haven't emailed me and you're not on the wait list, you probably should email me because that's still tentative about what we're going to do about people who still haven't even gotten on a wait list yet. All right, so first of all, you guys know what this is, right? Most of you guys probably took Comp 11 already, right? Most of you guys probably did. So you're kind of sophomores or above. This is the elephant, or the elephant. It's an elephant now. This is the cannon, right? I was walking by this summer and noticed this one. This is the best I have ever seen this, right? The best, right? This is what you should strive for, right? You should not strive for like sigma delta delta forever, right? Like, you know what I mean? Like half drunk. No, don't do no. Strive for the art. Okay, when I walk by it, I want to see art. I don't want to see, something like that. All right. Okay. Comp 15. Here's what we're going to talk about today. We're going to talk about 4 different lists. Actually, we're going to talk about 5 lists. One being the wait list. But we're going to talk about 4 computer science lists. We're actually going to kind of switch up the way a lot of classes happen. A lot of classes, like the first day, it's like admin, 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 and then like maybe some stuff. We're going to do kind of flip it. We're going to do a little bit of like real computer science first, then we're going to get into some of the admin. Okay? We're going to also talk about the instructional staff. That's me and some other people. Are any of the grad TAs here or the undergrad TAs? By the way, anybody TAing for Comp 11 this semester? A couple other people? You're here as a, sorry? TA. You're TA? Oh, nice. Okay. What's your name? Jesse. Good to see you. All right. So Jesse's here. Anybody else from any of the current TAs 415? Awesome. Welcome, Jesse. We're going to talk about that. We're going to talk about the assignments and the labs. This class does have mandatory labs. They are going to be Mondays and Tuesdays in the evenings, Monday evening and then Tuesday most of the day until right about now. Actually, maybe a little earlier. The sign up actually starts at 6 p.m. and it's kind of first come, first serve. You go onto the web page, which I will show you later, and you can sign up for the lab. If you don't get the only choice that you have available to you, email me and we'll figure something out. Okay, the labs hold about 24 students. Well, I think 22 is kind of the defined maximum, and we will figure it out. But all of you guys should be able to find some lab that fits into one of those slots. There's about 8 slots. There may be a 9th lab depending on how many people actually get fully enrolled in the class. Okay, we're going to talk a little bit about the course goals. I'm going to introduce you to Eclipse. So a number of people, most of you who took Comp 11 before, probably just used the command line. You did all your making of files by yourself and on the command line and all that. You used some editor, maybe Emacs or Vim or some other editor. Great. We're going to try to push you towards using what's called an integrated integrated development environment, an IDE. Namely Eclipse, which many of you may have used at some other point in your programming careers. And I think you will like it better. I'll show you a little later what it's all about. And I think you'll like it better than just using the command line. And then we'll talk about the assignments. Okay? All right, first things first. If you go to the web page, which I'll show you later, you'll see in the syllabus at the top it says, students will be able to solve real-world problems by making appropriate data structure choices tailored to the problem. That's a lot of words saying we're going to make you smarter about computer science, right? We're going to basically say, hey, you're going to solve some real-world problems, and you're going to learn how to choose the right data structure to do so. Okay, what does that mean? What's a data structure? We'll get into that. But the idea is you are going to have lots of different choices in how you can write your programs and what you can do to implement those programs and how you can store your data. And this class is all about making you choose those appropriately. Okay? I like to say that Comp 15 is really the class that gets you hired at Google, right? Because companies like Google and Microsoft and Amazon and all those big tech companies, they ask questions that we will cover in this class, right? They're not going to ask you, hey, how do you write a for loop? Right? They're not going to ask you that. They're going to say, hey, here's a huge for loop, and you're going to be storing all this data in it, and blah, blah, blah. What's the best way to store the data in it, right? And you're going to have to talk about that, and that's what we're going to learn in this class. Okay? We're also going to, and this is kind of related, we're going to analyze the costs associated with those programming choices. We're going to get a little bit mathematical, not much, just a little bit mathematical. If you've ever heard of a logarithm before, we'll talk a little bit about that, right? And we're going to do some analysis of those choices and say, hey, can you show me why this choice is better than this choice in the end? Okay, so we're going to do some of that, right? Let me highlight a couple other things. Choices, data structure, right? We haven't even talked about what a data structure is yet, right? But I do want to give you an example. Okay, let's see. Data structure choices tailored to the problem. That's kind of the key phrase right there. You have a problem, you need to solve it, make the right choices to make your programs efficient. Okay? All right, let's start with this example. This is the computer science part. All right, why are data structures important? Well, data structures are important because you don't like to wait for your computer to do something. Right? Isn't that kind of annoying when you're like doing something, your computer's just sitting there, and you're like, hey, computer, you're supposed to be fast. Let's just do something. Let's like get on with it and do it, right? Well, first of all, I should make a kind of a side comment. Most of the time, your computer's waiting for you, by the way, right? The fast thing in this whole equation is the computer, not you, right? I don't know if you guys, so when you guys are like writing a text message on your phone, right? When you're pressing the keystrokes to like, or the actual keyboard key, and the computer has to like register that key. When your finger is up off the keyboard, the computer is so fast, it's like, what's taking so long? I'm going to go to sleep for a little bit. Right? So the actual processor actually goes to sleep between key presses on your thing. Like that's how slow you are compared to the computer. Right? It can save enough battery by going to sleep between your key presses to make it worthwhile. Right? But in data structures and in lots of other things, we can actually come up with problems that do make the computer take some time. Right? So here's what we're gonna do, okay? We're gonna create 4 list-like containers. What do I mean by that? All right, here is a container, right? And what we're gonna do, that container, we're gonna put some integers in that container, all right? At the moment, I don't care how those integers are actually stored inside this container, right? What we're gonna do is we're gonna put 100,000 different integers into this container, all 4 of these containers, okay? We're going to tell the computer, store the following digits, right? The following integers, between 0 and 200,000, just the even ones. So in this container, you're going to get 0 and 2 and 4 and 6 and 8, all the way up to 199,998. And that's going to be what's going to be in each of these containers. I don't care from the outside how these are actually stored in here. I don't care if it's like an array, which hopefully you guys have heard about before in some capacity or another. If it's an array where you have 0 and then 2 and then 4 and then 6, right, all the way up to the end, I don't care if it looks like this from the standpoint of, are you storing my data and is it in there? Yes, right? I will care when I actually figure out how long it takes for some of these things. OK, so we're going to store 100,000 integers in here, okay, in each one of these containers that we create. Then what we're going to do is we're going to search for 50,000 of those inside that container. We're going to more or less pretend we don't have any idea what's in the container. We're going to say, hey, is 0 in the container? And whatever container we use, the container is going to come back and say, yep, 0 is in the container. And then we're going to say, hey, is 1 in the container? What are our containers going to say? No, because we're just storing the even ones, right? So then we're going to say 2, and it's going to say yes. Then we're going to say 3, and it's going to say no. Okay, and that's what all of our containers are going to do. Everybody with me? Okay. After we get done searching for them, we're going to I'm going to erase the memory and whatever, or we're going to erase our remembrance of what's in the container, and we're going to say delete the integers from 0 to 20,000. So we're going to say, OK, go, delete 0. And whatever container it is going to go find 0, and then it's going to delete it. And then it's going to go and find 2, and it's going to delete it, et cetera, et cetera, et cetera. OK? That's going to take a little bit of time. All right, 100,000 integers. That's not a huge amount. I mean, if you're Google, they laugh at things in the thousands, right? Google's dealing with billions and trillions of things, right? But for our purposes, 100,000 is actually a fair amount. OK? What are the results? Anybody want to guess, kind of guess some number about how long one of these containers, not knowing anything about the containers, how long do you think it's going to take to insert, search, and delete all those things in one container? Any ideas? OK. Is it going to be nanoseconds, seconds, minutes, hours, or days? Probably seconds, right? We're talking about things that are in the seconds range, right? Maybe, maybe not. OK? Let's see what the results are. Now, I'm about to show you the 4 different containers. You may never have heard of any of these before. I don't really care, right? The point we will learn about those as we go along. I don't care that you know actually what they do. And you like I said, you've probably heard of an array before. If you took a Comp 11, you've probably had a linked list before, right? But here's what the results are for these. And again, I don't care if you've never heard of some of these terms before. Here's what the results are. All right. So those are the 4, well, actually 5 different containers here. We've got an array. We've got a linked list. We've got this thing called a hash table, which you may or may not have used before or seen before. We've got a thing called a binary tree, which is kind of cool. And then we've got a sorted array, which is basically an array that we've said, hey, we know it's in order. OK? All right. Here's the results. How long did it take to do the array for that whole thing? It took about 10 seconds, right? 9.8 seconds. That's not too bad. Look at the linked list. Linked list took 23 seconds. Not good. I mean, in the grand scheme of things, not as good as the array. Did the exact same thing, and we ended up taking 23 seconds instead of 10. All right, but look at the hash table. Ooh, hash table is awesome, right? To do what we tried to do, the hash table takes 0.018 seconds to do all of that. Inserting, searching, deleting for all those things. That's fantastic. Binary tree, also pretty good. Again, you have no idea. We might not have any idea what those are, but just bear with me on this. Binary tree, not so bad. Sorted array, notice that it's about half the time of the actual array. So it's pretty good, but it doesn't come anywhere near as good as the other two. OK? Interesting. Interesting, interesting. If you look at the factors here, 537 times slower than the hash table. The array is 537 times slower than the hash table. The linked list is 1,280 times slower than the hash table. That's kind of a big deal, right? If you were to make the hash table go for 1 second, let's say you had enough integers that you made it go for 1 full second, right? The linked list would take 1,280 seconds, which is like half an hour or so, right? That's crazy. Like you would not want to wait half an hour for something like this if you could wait instead for 1 second, right? So there's the big difference. What have we learned about this? Just having no idea what any of these structures are, what have we learned in this case? Any ideas? Yeah.
Data structures vary widely.
Data structures vary widely, absolutely. What else? In particular, what else? Yeah.
The structure you choose is really important to see how fast you run.
Structure you choose is really important. Which one do I want to choose for this particular operation? The hash table. How did I find out? I timed it, right? I just timed it. I built these and I timed it. Now, I built these and I wrote this little program, which you can look at on the web page. I think if you go to the home page and then lectures, it's under there. It's called container test maybe. And anyway, I did not optimize it. If I'd optimized some of these things, the numbers could be wildly different, right? Probably not different in magnitude, but wildly different. Like it might instead of be, if I'd optimized the array, maybe instead of 9.8, it might be 2 seconds, right? And the linked list might be 12 seconds or 7 seconds or something. Hash table might be a little better. But if you ordered them in terms of overall time, you'd probably find out that even though they're not optimized, they're in roughly the same order. OK? So so we've learned a little bit about this, and these are the kind of things you might need to know if you're writing real programs, right? You come out of Comp 11, and you say, hey, there's this cool data structure called a linked list. I'm going to use it for everything, right? And you get to some company, and you build your first program, and it's got linked lists in it, and the thing is like slower than molasses, and you get fired, right? Why? Because you didn't take Comp 15, right? So because you didn't understand that there are definite reasons why you don't want to use linked lists in almost any case, believe it or not. We learn about linked lists because linked structures are used in lots of different ways. But the actual linked list itself, rarely used for real things. OK? Interesting. OK, here are the results for the overall and broken out by the individual pieces. And this gives us a little more information here. If you look at the array, inserting into an array is faster than everybody, right? Faster than everybody. Like if all you had to do was insert array, you would want to choose an array, right? In fact, you'd want to choose a linked list over a hash table if all you had to do was insert. Now, if all you're doing is inserting, what's the point of having a data structure at all? Because if you insert it and then never read it back again, there's no real point. But suffice it to say that the insert part broken down is an interesting perspective here. Arrays are great at that. Why are arrays great at that? An array, remember, an array looks like this. A bunch of boxes with a bunch of numbers in them, right? And all you need to do to insert into arrays to find the last number, which is easy, because they're all numbered by their address, and you just put it there. You don't need to do anything else, right? These other data structures, you have to do some other stuff. We'll get into what that's all about in a little bit. But what's the big discrepancy? And by the way, if you look at some of these other things, right? Searching through an array, very slow. Searching through a linked list, super slow. Searching through a hash table, wicked fast, right? So there's differences in searches too. Deletes are interesting. To do a search, right, you have to go and you have to find that number. So let's say we're looking for 6 here, right? In an array, if we don't know that it's in an order, let's pretend it's like random order. If we want to find a number in an array, how do we do it? How would I find a number in this? How would I find out if 6 exists in here? Yeah?
Go through and look at each box.
Go through and look at each box. Are you 6? No. Are you 6? No. Are you 6? No. Are you 6? Yes. OK, good. How about for 1? Are you 1? No. Are you 1? No. Are you 1? No. Are you 1? When do I stop? For this list? At the end, right? How about 3? When do I stop? At the end. There are no odd numbers in this list. Well, guess what? If there's no odd numbers in the list, you have to look through every single element and ask it, are you the one that I'm looking for? Takes some time, right? So that's one of the reasons that searching through an array is slow, right? What do you do to delete something? In an array, if you're deleting something, let's say we want to delete 4. Let's say I have 8 and 10, right? If we're deleting 4, what's the first thing you have to do? Find 4. Isn't that exactly the same as search? Didn't we just repeat the search and we say, are you 4? No. Are you 4? No. Are you 4? Yes. Delete. And then we delete it. Now, there's lots of different ways you can actually delete. We don't need to go into too many details about that right now. One way to do it is if you do care that everything stays in the same order that it was, whether or not it's in order, right? What do you have to do? You have to move 6 back to here, and you have to move 8 back to here, and you have to move 10 back to here, and that takes some time, right? What else could we do? What's a fancier way if we don't care what the order is? Somebody in the back? Yeah?
Take the last thing and put it there?
Take the last thing and put it there and just say, hey, our array stops right there now. Yep. We don't even need to delete that, by the way. Who cares? It's like random at this point, right? But that's the easy way to do it if you don't care about what order it's in. All right? So, and I did not do that for what it's worth here. OK, question. Why are the deletes so much slower than the searches if I just told you you have to do the search part before you get to the delete part? This is a tricky one, actually. It's a tricky question. Yeah?
Well, is the deletes for those for the user numbers? So I'm assuming it's because you don't have to iterate through the entire list every time you want to perform an operation. I couldn't remember the original example of that one.
You don't have to iterate through. You do still have to iterate through for all the evens. I mean, you have to go through and find with the even and then delete it.
Right. No, I mean the entire list, though. So if it's 2 and you find it,
Sure.
and delete it, you're not going to
OK.
keep looking.
True. But this is not the best example because this is actually fewer deletes than searches, so it's a little bit off. But in the end, if I'm doing the search, okay, let me phrase it like this. You're getting there, but if I do have to do the whole search again. So that part still has to happen, except when I delete it, what happens to the list? Yeah.
Once you delete it, the list
Once you delete it, the list is
becomes really
smaller. Yeah.
When you continue to delete it, it's like eventually becomes really smaller list, not really small.
Right, it eventually becomes smaller. So the point is you get a benefit out of deleting it for the next time you search. That's really what it is. So that was maybe a little tricky, but that's kind of the basic idea. So here's the discrepancies here. Like, why are there actually discrepancies? Well, first of all, some structures carry more information simply because of the design of that structure. It is all about information, right? Let's say I gave you a book, like the textbook for the class, right? And I said, find what page the following word is the first word on that page in, right? And I just gave you some random word and said, here's the book, find out what page this word starts, like is the first word on that page. What would you have to do? You have to look through the whole book until you get to that word, right? You have to look at every page and you say, no, 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 no. It's exactly like looking through the list here, right? What if I gave you a dictionary and said, find the page where the following word occurs? Right? You've got information based on the fact that the dictionary is in alphabetical order. Like, that is information right there. And that information is the key to why we can make some of these things faster. Okay? Here's the dirty little secret. Everything's an array. And here's what I mean by that. A computer, I think this is on a later slide actually, a computer knows one thing. A computer knows there's a bunch of memory addresses here, and each memory address, I can put a value there. That's all it knows, right? So however your data structure looks, whatever your data structure looks like, at the end of the day, it's put into an array of some sort. Now, that array can be the whole computer memory, and part of it can be here and here and here. But the bottom line is, the information comes from the fact that you know that you've created a hash table, or you know that you've created a binary tree, and you know the structure of it, which is just information. Okay, so that's kind of the bottom line there. Now, second thing about this, we kind of already talked about this. Manipulating some of these structures takes some time. What do I mean by that? When you're doing that delete and you have to move every integer backwards one, that just takes time, right? So things like deletes take time to do that. It takes time to look through each element if you have to do that, right? That's where the like manipulating the structure or looking through the structure actually takes some time. Okay, so this is kind of a reiteration here. The computer knows one thing, memory's laid out in one array, and you get information by knowing what the structure is by the basis of your the actual data structure we're using. Okay, and then finally, well, I guess to reiterate again, manipulating the structures takes time. You need to figure out how to put the data in the right place. We will spend a lot of time saying, hey, how is this going to end up laid out in memory? Because that's important to how much you actually are able to take advantage of the information. Okay, here's a couple more things. Searching through an array versus a sorted array. Look at the difference in time. All right, the array takes 7 seconds. The sorted array takes 7/100ths of a second, 7/1000ths of a second, right? How do I search through a sorted array? Any ideas? Yeah. You can use inequalities. Yes, let me expand on that a little bit. You guys have all played the following game and probably programmed it, possibly in some programming class, but the guess my number game. Guess a number between 1 to 100. Right? I'm thinking of a number between 1 to 100, and you guess it, and then I tell you whether you're lower or higher using inequalities, basically, right? So if we're going to play that game, and I'm thinking of a number, what's the first number you're going to guess? 50, right? Unless you're like 6, and you're like 12, and then if you don't know the idea, right? You guess 50 because at 50 you split the list in 2, right? And then I say, oh no, it's lower. What's the next one you guess? 25, right? Because you've split the remaining in 2. Right? This splitting in 2 is actually a logarithmic idea. In other words, the logarithm in base 2 is by splitting in half, 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 half. And if you do that, you can get all the way down very, very quickly. Okay? You do the exact same thing in a sorted array, right? You say, okay, if all these numbers are in order, the first one I'm going to search for, if I'm searching for 7, I'm going to go to the middle and see if it's lower or higher, and then go, and if it's lower, then I'm going to go to the middle of that and the middle of that, and do that in that order, right? So that's how we can make the information based on being in order available to us to do searching really fast, right? Okay, deleting's pretty fast too, but you still have to do the searching. Same kind of idea. All right. Okay, inserts though. Now, keep in mind, I didn't optimize this. There's probably a better way to do it, but inserting into an array was really fast because we just tack the next number on at the end. Boom, 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 boom. Inserting into a sorted array, what do you have to do? Like, there's various ways to do it, but what's one way to do it? Yeah.
Is it for the same reason why it's faster? In the other case, you have to compare it.
You have to compare all the ones, right? And then what do you have to do when you get, if I want to insert, let's say this is 0, 2, 4, 6, 8. Now I want to insert 5. I find where it's supposed to go, and then what do I do? What do I do? You have to move every one of these. I have to move 10 here, and 8 here, and 6 here, and then put 5 in there. It takes time to do that, right? That's one way to do the insertion sort. There's other kind of better ways, but that's the way I used it here. So that's why it takes so long to actually insert, because you got to get the list in order to begin with, right? But once it's in order, searching is great. Okay, and I'm sure you can think of various times where you would want to use one or the other. If you're going to do lots of searching afterwards, put the list in order, right? If you're not going to be doing a lot of sorting or searching, you might not need to worry about it so much. Okay, and you might gain the benefit from not doing that. Okay, all right. So actually, that was where we ended for the computer science part of today. Any questions? Kind of get the idea of the types of things we're going to be talking about in this class, right? The basic idea of, hey, we have to think about what structure we have and what form, like how we're going to access that data, and bear in mind everything in the end is always in some array-based form in the bottom line. The information that you have gives you the benefit of speed. Okay, question, yeah. What do you think? Is time the only thing we're going to optimize? What do you think? No. Good answer. No. What other things could we optimize for? Let me give you. Go ahead. Space. So I'm going to date myself here, but the first computer I actually ever really played around with was my grandfather's computer. It had 4 kilobytes of memory. 4,000 bytes of memory, right, in that thing. And I didn't even have access to all of that, right? I had access to 2 kilobytes worth, right? I tried to write my first program and ran out of space. I'm like, oh great, now what? But yeah, you definitely have to optimize for space a lot of times. Are we going to talk about that? We are going to talk about that probably in the last project. You're definitely going to have to consider space in some of the, because we're going to actually be, the last project that we're going to do is going to be using a database that's about 200 megabytes big, which isn't huge, but if you're trying to keep it in main memory, it's kind of big. So you have to, you'll have to think about that. Yeah, good idea. Yeah?
This is a random question.
Yep.
Assuming whatever processor this is run on doesn't tune down its clock speed, just stay stable, would time be a good estimation of this power consumption too? Because fundamentally,
would time be a good estimation of the power? That's not a bad idea. Yeah, in general it is. Although it's a little tricky because you can take the longer you take, yes, the more power, right? But at the same time, I mean, it's not a linear relationship in that. It's not necessarily a linear relationship. But yeah, definitely. Yep. If you build a more efficient data structure, it takes less time, you'll probably use less energy. Yep, absolutely. All right. Other questions on this stuff? No? OK. Let's talk a little bit about admin. Switch gears a little bit. All right. First of all, I mentioned this a little bit earlier. Enrolling for this class has been a bit of a challenge because there's caps on classes. It looks like we're not going to worry about that Although, like I said, if you're not already on a wait list, we should probably talk because there may not be the availability if you're not already on a wait list. The forms are here if you need to fill those out. You can certainly talk to me after class about any of these issues. I don't care which section you go to, right? If you want to come to the 431, that's fine. If you want to go to the 131, that's fine too. The 131's in a smaller room and just about as many people, so it's jammed in there. What I'll do is I'll prefer seats for people who are actually in the class, right? But you're welcome to go to either. The other part about that is that if you notice, there's a camera back here. I'm going to be videotaping every class and putting it on YouTube. So if you have to miss a class, or if you want to miss a class, then just miss the class and watch the video, right? I mean, that's completely up to you. The benefits of coming to class are that you get to ask questions, and it's in general probably a little easier to watch me in person than droning away on a video, right? I mean, there's nobody like panning and it's like one shot, right? But you're welcome to do that. The flip side is if you come to office hours and you say, oh, hey, Chris, I didn't go to lecture on Monday. Can you tell me what we did? I'll say, well, did you watch the video? And you'll say, oh, no. I'll say, goodbye. Go watch the video and come back when you're done watching the video. OK? So you're totally welcome to do that. Yeah?
I guess another thing that comes to mind just randomly is probably that our stupid questions will be immortalized in that, right?
Yeah, there you go. Your stupid question will be immortalized. I had to, last semester when I did this, I had to cut out a couple of jokes that I told that I thought, yeah, the general YouTube populace doesn't need to see these jokes. But anyway, OK, so that's the idea about coming to class. I mean, look, if you're not here, it's more space for the rest of us, and you can still get it from the video. But just be judicious about it in your own learning style. Okay, the other downside is I might not learn your name. Like I'll never see you and I have no idea. I will do my best to learn everybody's name. I can't promise 100%, but I'll do my best. OK, lab sign up. So as I said, there's or maybe I didn't. There are labs Mondays and Tuesdays. Sign up is 6 p.m. tonight. If you can't go if you don't get into your section that you want, and the website will be up here a little later, then email me. We'll try to work something out. OK, it looks like there's going to be about 7 to 8 lab sections. OK, any questions on that? Oh, good. All right, so let me introduce some of the people in the class. So I'll talk a little bit more about me in a second. I'm sorry, I already forgot your name again. Jesse. Jesse is here. He's one of the TAs for Comp 15. Undergrad TA, though. Yes, awesome. So on the one person you will probably know just from hanging around the labs in Halligan Hall is Bruce Mollet. Some of you guys already know him. He's the guy who gives popcorn out and like helps out with projects, right? And he's awesome. And you should get to know Bruce because he will help you with any project and he will spend lots of time with you. And it's difficult to annoy him. What definitely annoys him is if you come to him and you haven't really thought the problem through at all, right? If you don't have a diagram and you don't have you're just like, I don't know what I'm doing here. My program's crashing. If you don't have a diagram, he'll go away, draw me a diagram. You'll figure it out, right? He likes short functions. He likes, well-formatted code, all that kind of stuff, right? But he's great. Okay, you'll see him around. We have a few graduate TAs. Anybody show up? How you didn't show up, did you? No. Okay, we have a few graduate TAs who are going to be helping out with the class. And then we have about 1 million people like Jesse who are going to help out in labs and things in the undergraduate end of things, okay? And some of you guys are TAing for Comp 11 this semester, which is great. And if you do well in here, there's a good chance you'll be able to TA next semester for either this class or Comp 11 or whatever. Okay, it's kind of fun. Jesse, how many times have you TA'd now? This is the first one. OK. You will quickly find out that you become a much better programmer by TAing, because you learn better as you try to teach somebody something, right? So that's a benefit of that. OK. Now, who am I? All right. Let's see if I can pull this up. This crashed on me earlier. This is Google Earth through my Windows instead of my Mac because it wouldn't run on my Mac for some reason. Let's see if oops, I already screwed it up. Hold on. I just want to make this bigger. All I want to do. There we go. OK, Google Earth. There we go. So Chris Gregg, I grew up here, a little place called Skinny Atlas, New York. This is like way back, right? Yeah, a little place called. Anybody heard of Skinny Atlas before? Anybody from Central New York, upstate New York? Nobody? All right. Well, Anyway, it's a tiny little town. There's a beautiful lake here, and that's where I lived until I went to Johns Hopkins University in Baltimore, Maryland, and I studied electrical engineering there, and loved it. Spent about 4 years there. Studied electrical engineering. Tufts was one of my top choices as well. I ended up at Johns Hopkins, but that's where I spent 4 years and had a very good time doing that. Took a lot of computer science classes as well. I actually took a data structures class. I took it in a language called Pascal, which probably you guys have never even heard of, but it's a language a lot like C, and it was kind of all the rage like 25 years ago, right? So anyway, so that's where I went to college. After college, I decided to join the Navy. Why did I join the Navy? Because they sent me a letter, of course, right? They sent me a letter and said, hey, do you want to join the Navy? And I said, yeah, all right, I'll join the Navy. And I ended up being as you do, I ended up being a cryptologist in the Navy. I'm actually still in the Navy Reserves. Let me see. I think somewhere around here I have, there it is, my alter ego. Right? That's me looking goofy in my uniform. I'm a commander in the Navy Reserves. Anyway, so I went to the Navy, and the Navy sent me to a whole bunch of cool places, one being San Diego, California. Any Californians in here? Yeah, where are you from?
I'm from Bay Area.
From Bay Area. I love the Bay Area. Where about you?
Santa Cruz, California.
I lived in Santa Cruz for a year. Taught high school in Santa Cruz at a place called Pacific Collegiate High School.
It's a good school.
Yeah, it's a great school. Yeah, small little school, but yeah, love California. I would go back there all the time if I could, but I live on the East Coast now. Anyway, they sent me to San Diego. I spent a couple years going on ships, visited a ton of great places like Australia and Thailand and Malaysia and a lot of places in the Middle East, and that was kind of cool. And after I got done with my a few years in San Diego, the Navy said, where do you want to go? And I said, this is like completely off the top of my head. I'm like, how about Australia? Thinking there's no way they're going to send me to Australia. Well, guess what? They sent me to Australia, right? They sent me to a tiny little place called Gerringong, Australia. Any Aussies in here? Sometimes we get a couple. Last year I had a person who was like from this town or whatever. It was crazy. Anyway, I spent 2 years in Australia, which was awesome. I got out of work at 4:30 and went surfing every day. It was great. And I did that for a couple years, loved it, and then decided, well, I'm never going to find another job in the Navy that's as good as the one I'm in right now, so I better leave the Navy. So I got out. I decided, you got to make those choices, right? You got to weigh the things, right? They were going to send me to some ship out of like Norfolk, Virginia or something, and no offense to anybody from Norfolk, but I'd rather be in Australia. Anyway, so I decided, hey, I want to be a physics teacher, and I want to go back and teach high school physics. So I actually came back to this coast to a little place called Harvard, got my master's degree in education there, and spent a great year there doing kind of learning to be a teacher. And then after that, that summer, I actually got to go to Ireland to write for a travel guidebook. It was awesome. Spent a summer doing that. It had nothing to do with computer science or physics or anything. And then I came back and ended up teaching at Brookline High School. Any Brookline High School people in here? Nobody. We had somebody in the earlier class today. In fact, she was her physics teacher was my mentor teacher at that school, and she's awesome. So that was cool. Anyway, I taught at Brookline High. Anybody from Newton North? No? No, OK. That's a rival, Brookline High. Anyway, so I taught at Brookline, and then 1 year I was in Santa Cruz, California, teaching out there, and then came back to Brookline. Yeah, Santa Cruz is awesome. Keep Santa Cruz weird, right? As they say?
It's
Yeah.
still weird.
It's still weird,
It's
yeah.
still-
Yeah, it's a great place. Did a lot of surfing in Santa Cruz, too, which was cool. Anyway, came back to Brookline, and then after a few more years there, I said, hey, I think I want to go get a PhD. And so I enrolled at the University of Virginia. This is where it crashed last time, by the way. Oh, no, it's going to make it. Enrolled at the University of Virginia and to study computer engineering. This is actually this is the stadium. Our building, this is the brand new building right here. That was the building I ended up the last couple of years in. And I would sit in this office up here and like listen and kind of watch the football games from like the top of the office there. So I couldn't really see the field, but I could hear all the screams when people scored. That was kind of cool. Anyway, UVA was cool. Got my PhD in computer engineering, and then decided, hey, I want to go be a professor somewhere. Interviewed a bunch of places. Interviewed at Tufts, and Tufts said, hey, we'd love to have you come here. And I said, I'd love to come here. And then the Navy Reserves called, and the Navy said, we're going to send you to Africa for a year. You don't have any choice about it. And I said, oh, I have no choice? They said, no, you don't have any choice about it. So it turns out when you're in the reserves, they make you do this every so often, go on a mobilization somewhere. In fact, they also make you do, like 1 weekend a month, you have to go and go somewhere and do your drilling. I happen to have to go to Seattle, Washington once a month. I have to get myself to Seattle, Washington once a month, which is not too fun, if you ask me. I mean, it's great being in Seattle, but it's getting there is not too fun. Like this weekend, I have to be there. Anyway, so the Navy said, you're going to Africa. And I said, awesome, Africa. I'm going to see giraffes and lions and elephants and whatever, right? And they said, well, you're going to a little place called Djibouti, which is a tiny little, anybody here ever heard of Djibouti? Yeah, it's a tiny little country. It's like 12 miles north of Somalia, like the most dangerous place in the world, right? And it's a lot of dirt and a lot of like hotness, right? And there's no animals, and there's no foliage, and I didn't get to see, well, I did get to see a giraffe when I went to Kenya, but that was about it, right? So that was kind of not so fun. And I called Tufts and I said, hey, the Navy's sending me away for a year, and they said, oh, well, too bad you can't work here. All right. And then as it turns out, when I was over there, they had some other faculty openings, and luckily they called me up. Luckily for me, I'm not so sure about you. But anyway, they called me up and said, come work here. So that was about 6 months ago I got back. I was here last semester, and this is my second semester here. So that brings us up to here. Oh, here's, let's see, here's where in Djibouti this is, or in Africa this is. There's Africa, and it is way up here. I don't know why it didn't zoom in, but that's where it is, right here, right in the Horn of Africa. Right? OK. So anyway, that brings us to here. Questions about me? No? Good. All right. OK, so that's the staff. You will see a lot of us. OK, please go to office hours. I will say this a number of times. Go to office hours if you're having trouble with any of the projects. OK, we do a lot of projects in here that can be tricky for people. OK, I'll talk a little bit more about that aspect of the class in a second. In fact, right now. Who's this class for? OK, I already said this class is like how to get a job at Google, right? That's one of the, like if you want to get a job at Google and you want to be a computer science major, this class is A, required, and B, like a great place for you to be, like right now for this semester, right? CS minors, if you're minoring in CS, you can also take data structures, and I think you'll enjoy it. Obviously, it's another, I don't know if it's required, but it's most of the follow-on classes require this as a prereq, so you have to do that. Other majors that have Comp 15 as a requirement. So any cognitive brain science majors in here? Yeah, a whole bunch of you guys, right? Now you guys have to take this class, right? Just like the computer scientists who love it, right? And you guys may love it. Awesome. If you don't love programming, I still welcome you into the class, and we will try to make this as pain-free as possible. All right? Like if you're like in Comp 15, you're like, oh my gosh, I have to take this class, and I don't want to program, and blah, blah, blah. We will get you through this. If it's kicking and screaming, we will still get you through it, right? You will do fine. You just do have to know that it is a pretty intense amount of programming, and there's kind of a lot to learn. But please don't let that scare you away. If you took Comp 11 already, and I assume anybody who's a cognitive brain science probably did, then you should do fine in here. You are well prepared to start out class here. Okay? And of course, anyone else who wants to learn more than the basics of programming, right? This is not really a programming course. Like we use programming, we do a lot of programming, but the programming is kind of a means to an end, right? The end being, hey, here's these interesting data structures. Why are they better than other ones, and how do we format them, and so forth, right? The programming part is kind of a little bit of a side part of that. Okay, so don't come in here thinking, oh, I'm going to just learn how to program. No, you're going to learn a lot more than that, and because this really isn't a programming class. Okay, all right. Questions on that, right? If you have questions on is this class going to kill me or not, speak up now. Oh, I should mention, a number of you don't raise your hands because you're freshmen, and raising your hand in a big lecture hall as a freshman is intimidating. But for those of you who are freshmen, if you have not spoken to me prior to being here, You need to, like you snuck past me somehow, right? I have to be able to, like, let me step back a sec. You are certainly welcome in this class. If you don't have C++ background or a strong Java background, what I mean is if you got an AP on a 5 on the AP computer science exam, or you've done a whole bunch of programming in Java or C++ on your own, then we should probably talk about whether or not this is the right class for you right now. Okay, Comp 11, which teaches you C++, which is what this class is based on, is a much more gradual introduction into C++. And if you didn't do that well in AP, or you're here because you think, I can learn to program, whatever, please talk to me, because we need to make the right choice. What I don't want you to do is get 2 projects in and be like, I have no idea what's going on here. I've never programmed in C++ before, and I'm completely lost. That's like the last thing we want to do. We want to make sure that you're in the right place. Okay? Make sense? All right. Graduate students included, people who are like have never programmed before, talk to me. Most of you guys already have. Okay. Questions on who should be here and who shouldn't? You all should be, but whether or not now is the right time is a different question. Okay, this is an important slide. Lots of resources. The main resource, this is where you go, and I think the first or second announcement on there talks about the lab sections, which you can sign up for starting at 6 p.m. Right? Go here and find that. This will be where I put announcements. All your assignments are going to be on there. All the lecture notes, all the videos are going to be, the links to the YouTube videos, all that are on the website. Piazza. Most of you guys have used Piazza before if you were in Comp 11. Piazza is just a forum for asking questions in class. We'll talk a little bit about what you should put on Piazza and what you shouldn't. Namely, you shouldn't put like code, like lots of code on there. If you're asking more general questions. Okay? Oh, I forgot to mention this in the other class. I'll have to remind myself to do that. There is an anonymous feedback. If you think what I'm doing is, if you think something's like up with what's going on in class, like you didn't like the way I presented something, or you think you have some constructive criticism or whatever, and you don't want to email me because you think it'll affect your grade, it won't. But you can use the anonymous feedback. Just go here. You can say whatever you want to me. I promise I will read all the anonymous feedback. You can set it up so that you can get me to reply, and like so you're still anonymous. Like we can still have a dialogue while you're still anonymous, and it's good. It's a good way for like low stress feedback if you want to do that. As I said, I promise I will read them all. If it's not constructive, I'm not sure I'll really reply or have much to say. I mean, if it's like, oh, that class sucked today, well, that doesn't help me much. Like, tell me why, right? Stop talking so much. Don't do as much. For instance, I got some anonymous feedback last semester that said, look, you're doing too many code examples on like the overhead projector. It's like too much code to read in one class. That kind of feedback, I was like, great, okay. So I talked about it with the class, and we made less code examples like that. So get the idea. Anonymous feedback's good. Feel free to use it if you don't want to email me. But of course, you can email me as well and say, hey, this is what I did or didn't like. Okay, office hours. So I'll have some office hours on Tuesdays and Thursdays, I think. I'm pretty sure that's when it is. You're welcome to come to my office hours. My office hours tend to have big lines because people come and they want to chat about various programs, and I'm like one person, right? TAs will have lots of office hours in the labs. They will be in the labs a lot of the time. You should definitely go there and use those resources, right? Go in there, work on your project in the lab, grab the TA, say, hey, I don't understand what's going on here. Why is my program crashing, et cetera, et cetera. Okay? If you can't make my office hours and you really do need to meet me, fine, email me. We'll make a time. Okay? I already mentioned the videotaping. Email, yeah, look, just use it sparingly. If you need to email me about something, great. If it's something that you think could be better answered on Piazza, just ask it there, and you'll probably get an answer quicker too. Okay? Question on the resources? No? All right. Textbook. Okay, so this is the textbook that you can go and purchase. What it is, it actually says custom. It's for Tufts. What it is it's actually a part of a larger book. And when I talked to the guy who sells the books, I said, your book's kind of expensive. He said, well, look, I can make it, like I can put only parts of it in there if you want, if you only do certain chapters. And I said, is that going to be less expensive? He said, yeah, a lot. So it's like 50 or 60 bucks less expensive for this version. Now, you don't get all the extra stuff you get in the other version, like some of the stuff we don't cover. So it's not quite as good of a reference, but it's less expensive. Now, that said, if you're really cheap and you don't even want to buy this, I'm going to put there's a second book online that you are completely free to use as well. I will give alternate reading assignments from this book as well that mirror the ones from this book. They're not identical, right? But, and feel free to read both, by the way. Okay, most reading assignments are relatively short. But you can read them from here and not buy the book, or you can buy the book and do both, and whatever you want. Okay? Question?
Yeah, if we have a book from a previous semester of the class, how far back would that be applicable?
How far back previous for this class? It is going to be a different book, but it probably has most of the same topics in it. So I mean, if the topic's heaps, you'll be able to find heaps in the other book probably. So feel free to see how that goes. I mean, if it comes down to it, you can always purchase this book later, or go to the online one here. Okay? Yeah.
Which book is better?
Which book is better? So I think it's a good question. I like this one because it's pretty well written and it goes into enough depth. And I think from a textbook standpoint, it really goes into the depth you need for this class. This one, I haven't read through it all, but I mean I've read through as much as we're gonna do. I guess I don't like the examples quite as much for this one. This one has some pretty good examples, but it's up to you. You could, if you want to borrow a book, I can lend you one, and you can read through part of it and make some comparisons. Yeah. Other questions on the textbooks? Yes.
Are either of them ever available for reference at the library?
There are no. Well, this one's online. I mean, this one's just like it's literally a PDF. So that one's available whenever you want, as long as you have a computer and online. This one, I can probably get some at the library. I probably put one or two at the library. There's definitely one or two in the computer science office, but the library is probably a better place for it. I'll talk to him about it. So if you wouldn't mind, just email me and remind me. Talk to him about it. Cool. Other questions? Textbook? No? All right. OK, as I said, this class is in C++, which means if you don't know C++, you have to become a decent C++ programmer. If you took Comp 11, you are well prepared for this class. Okay? Don't think that you're not just because you didn't do necessarily so well. You did a lot of stuff in Comp 11 that you're well prepared for this class. Okay? C++, not my favorite language, actually. As it turns out, there are lots of different choices. There's like thousands of different languages, right? C++, we teach C++ here for a number of different reasons. Have you guys heard of Comp 40 in class? Yeah, a lot of people have heard of Comp 40. It's a pretty tough class. That's in C, which is kind of a subset, not really, but more or less, a subset of C++. And so if you already know C++, the transition to C is relatively easy. If we taught this course in Java or Python or some other language that's arguably, I'm not sure Java would necessarily be easier, but Python certainly would be easier in some sense, you wouldn't necessarily be as ready for Comp 40 for those who are going to take that. So it's a bit of a trade-off. The other analogy I like to use is learning C++ is it's a little bit like having the first car you own or drive be a Ferrari, right? So a Ferrari is like not an easy car to drive, right? There's like lots of gears and it's a really tight stick and this and that, and it's hard to drive, and you end up like burning out clutches, and you end up stalling all the time and all that. But once you know how to drive a Ferrari, you can pretty much drive any other car, right? That's kind of the same with C++, right? You learn C++ and you're like, oh my gosh, this is really hard. Once you know C++, it's pretty easy to learn a lot of other languages. Python you could pick up in a day once you know C++. Yeah? Why is this class not taught in C? That's a very good question too. So C, it's even more low level, and I want you guys to have strings. And I like the idea of knowing about object-oriented programming, which is what C++ is ostensibly. And you'll probably use that later in life. And quite frankly, interviewing, people like it better if you know C++ than C. So that's another reason. Yeah. But most of it, I mean, honestly, the difference between what we do in C++ and C is minimal in this class. Yeah. Other questions about that? If you are just a Python programmer, I've talked to a couple people who say, yeah, I know some Python. That's fine. You are going to have a pretty steep learning curve for C++. Right? If you're a Java programmer, the transition isn't too bad. It's not trivial, but it's not too bad. Okay? Feel free to talk to me individually about this. If enough people want it, I'd be happy to have a TA or somebody do like a review session or kind of a getting up to speed in C++ over the next couple weeks. So we may do that, one or two sessions of that. Okay, I can't promise too much, but 1 or 2 sessions. Okay, look, you got to put the time in to write your assignment, to do your assignments, right? You got to have time to get help. For those of you who took Comp 11, how busy were the labs the day before projects were due, right? It just gets jammed in there. Why? Because people don't budget their time and start early, right? If you start early enough, you can get help early, and you can go, right? You can go in when the TAs are there and nobody else is there, right? There's lots of hours where the TAs are just like, OK, I saw like one person tonight, right? And versus where you go in the day before it's due, and there's 40 people and 2 TAs, and the TAs are ripping their hair out trying to help everybody. So not the best way to go ahead and do it. Follow all directions for submitting. This is really important. We do a lot of auto grading in here. Auto grading, and I'll show you what this means in a couple minutes. But we do a lot of auto grading where we submit you submit your program to the homework server, the CS department's homework server, and it runs your program through a bunch of other tests and tells you immediately whether or not your program passed or failed the tests. Right? I think we've got it set up pretty well this semester so that you'll get good feedback on that and be able to integrate some of the tests of into your own programming. Excuse me. You should always write your own tests, okay, for your code. We will check lots of corner cases, meaning if there's a situation in a data structure where it's like the edge case, where it's maybe the last element in the array or the first element or the last element in a linked list, right? You have to handle that specially. We will test that. I guarantee you we will test whether or not you've handled that case properly. So you need to test your own code for that. We will try to grade the assignments in a timely manner, which means like within a week after you submit them, when they're due. And we'll give you feedback. Use the feedback wisely, right? If we give you feedback, use it. Like if we say, hey, you need to make your code cleaner, make it cleaner, etc. Okay? All right. Most of you guys probably already have the Unix accounts. If you're freshmen, I'm not sure it worked right. They try to do it automatically, but you may not have seen an email about your CS accounts. You should see those in the next couple of days. If you don't, we'll talk next week and make sure that you have those. We're going to be using the Unix shell a lot. If you're in Comp 11, you'll know what I'm talking about. Otherwise, you need to get used to working around using the Unix shell, like listing your files, changing directories, et cetera, et cetera. Okay? I'm going to suggest, I said this earlier, I'm going to suggest we're using Eclipse. All right, but you might also, if you want to, you can use plain text editors. You can use our make files, which will make compile all your programs for you. You can use Xcode. You can use Visual Studio, whatever you want. If you have a way that you program that fits your method and your way of going about it, awesome. Do it your way. I don't care. Most of my examples will be from Eclipse. Okay? All right. Eclipse is what? It's an integrated development environment. Okay? Here's the benefits of Eclipse, and I'm going to show you in 1 second. All your files are in one window. Okay? Instead of having a bunch of files there and you pull one up at a time, you pull another one up, and you close the other one, they're all there. Right? There's a built-in debugger, right? Which means that you can click on a line and say, run my program until it gets to this line, and then stop. And it will stop, and it will tell you what all your variables equal right then, and it will tell you what your pointers point to, and it makes debugging so much easier. Right? It takes a little time to learn how to do it, but it makes it so much easier, right? Let me see if I can do this now. Here we go. OK. Here's what if you have a Mac, all this is already built in. Well, you have to install the X11 Windows system. It's not hard to do. It's online, how to do that. If you have a Mac, you open up a terminal. Windows, you can do it through a separate program. And if you SSH, in other words, if you connect into this homework server, you do it like this. You say SSH-uppercase X, your username, your CS username, and then homework@homework.cs.tufts.edu, and you'll then be, as long as it works, taken to, as long as my computer is connected. It is, just taking forever. And you'll be connected like this. If you type Eclipse, well, if you do an ls, right? That gives you the directory listing. Let's see. Homework 1, I believe I have in there. Yeah. Here's all. Here, let me show you. Here we go. Here's all the programs I have in here. Okay. I will give you these things called makefiles. We'll talk about that means in a minute, and a whole bunch of other files that you'll need to use. If I type it right, Eclipse. If you run Eclipse, it should open up. If you're on campus, it will be much, much faster than if you're off campus. If you try to do this from off campus, it could be kind of laggy, and you won't like it so much. You can certainly install Eclipse on your own computers. It's a little tricky to get it right with the C++ especially, but you can do that. Uh-oh, why is my, I don't know why did I not, hang on. Let me see this again. Looks like it might have deleted my project file, but that's all right. No. Where is it here? Let's see. Eclipse. There it is. Maybe. No. I forgot where my folder was. Hold on. Nope. There it is. Workspace. Yeah. OK. Let's see if that works. OK. So you pull up Eclipse, and it will come up, and it will hopefully, there we go, show you your projects, right? And watch this. Here's your project files. And this happens to be the one from the container test I showed you earlier, right? Here's one of the files. If I want to look at hashtable.h, I just double click on it, and it brings it up here. And then I look at all my stuff here, right? And I can just change something. So let's say I put a bug in here, and I say blah, right? Well, that's a silly bug. Let's say I tried to make, I don't know. Well, let's say I just called, instead of unsigned, let's say I said unsign a int, right? And I do that. I don't know. It's probably hard to see from the back. Sorry. And all you do is you click this little thing up here that makes it, and it does all the compiling for you, right? Does all the compiling, and then it tells you where the errors are, and it points out, hey, there's your error on this line, right? And it actually, we're going to be using the Clang++ compiler instead of the G++ compiler. Clang++ is great. It gives you great error messages. Look, it pointed out exactly where on the line the problem was, right? And then I can click there. If I double click there, it actually highlights it up here. And I go, oh, yeah, you're right. It's unsigned with that. And then rebuild, and it's good to go. See how easy that is? Like I said, you can do a little breakpoint. I can click like, let's say I clicked right down. This is not a good example. Let's say I was over in hashtable.cpp, and I clicked on this line here, and it put a little dot right here. It's hard to see from the back. There's a little dot there. If I ran the program, it would stop on that line and tell me all the stuff that's going on in the program right then. Pretty cool stuff. Okay? If you look at the Eclipse tutorial, which is homework assignment 0, shows you how to do this. Okay? And shows you how to set this up. So give that a shot. You can do it from Windows or Mac. You can set it up to work fine. Question? Yeah?
What directory is the Eclipse in?
Just run Eclipse straight from the regular command line. It should run fine. So if you are in, let me close this out. If you're in the server, you should just be able to type Eclipse, and it should run. Did it not work?
I'll
Try it again. But anyway, it should be right there. Question?
You need Xcode for that, right?
You do not need Xcode for this. No, if you have it on your own computer, you will. But this is what this is doing, running Eclipse from the server, and then pushing you all the windows. So it's actually running on the server computer. Other questions? Yeah?
Are we allowed to, for example, set up a Git repository from the server so we can just push to it?
The server's already got Git stuff. Yes, you can do that. Sure. Yep. I'll try to have most of the projects in Git. If you don't know what that means, that's all right. I'll probably try to have most of the projects in Git to pull from it anyway. But you can set your own up. Yeah. Git's already installed. Other questions? OK, good. So what does that lead us to? Whoops. It leads us to Eclipse. A random slide on plagiarism. Don't share your code. You can work with other people. I highly suggest working with other people, right? And you can help somebody. But don't share your code. I don't want to see two people have the same the same program or the same functions or whatever. Most of your functions will be similar because they're doing the same thing, but they should not be the same. Okay, and we can tell. We run them through programs that compare, and they can very easily pull out whether or not you copied code from somebody else. You can discuss the assignments. If you discuss an assignment with somebody, put their name in the README file that you have to submit and say, hey, I talked about this part of the program with so-and-so. That's just giving them credit for what they helped you on. Okay? You don't have to cite me or the TAs, but you have to cite your own fellow students. Okay? Don't ask for questions on Stack Exchange, like Stack Overflow. Right? You can do that, but they'll yell at you because they know. They can see right through it. If you want to ask generic questions about things, sure. If you can't figure out specific something, fine. But most of the time the answers are either there already or they know it's a homework question. I have to put this in for legal reasons. If you write something that you want to go make money on, don't be surprised if Tufts comes and says, you owe us some of that money. If it's in class, you won't get that. I'm not going to give you stuff that you can probably make money on, just for what it's worth. Getting away with cheating is becoming harder and harder, probably harder than you think. We have tools, and Bruce, by the way, writes all these tools, and he loves catching cheaters. So just so you know, if you're not a cheater, you have nothing to worry about. If you do cheat, Bruce will love catching you, and I'll love kicking you out of class. So don't do that. All right. Look at the class syllabus for grading information. Grades are going to be on Trunk. So I'm just going to put your grades themselves will be posted on Trunk. I'm going to try to do that. It's not hard to use. It's just going to be your grades. Everything else will be on the regular website. Okay. If you think you're going to struggle with the programming, please come for help early. Okay? Come for help early. I don't want you to get to project 3 and have no idea what a pointer is. Right? That's going to be bad news all around. You're not going to do well. Okay? And go to the office hours. Okay? Questions on the class in general? Anything else? Okay, let's talk about the homework assignments. Homework assignment 0. Do this Friday. This may not be possible if you can't get your computer science accounts yet. But if you can, then watch the Eclipse setup video and try to get it so that you can log in from your computer. During the first lab next week, you'll be able to. The TAs will help you set up Eclipse as well. Okay. Enroll in a lab section. That's 6 p.m. tonight. Go to the website. The thing's on there at 6 p.m. It should come on. If it doesn't, I'll get 200 emails saying, why isn't it on? So hopefully that'll be on. That's assignment 0. Assignment 1. So assignment 1 is going to be due next Friday. That gives you a little bit of just about a week and a half. It is not a trivial assignment. Okay, what I've given you, and it's posted on the online, what I've given you is basically I've given you a .h file, which tells you what all these functions are. And I've given you some what I call boilerplate code, which is basically I've filled in the details in a .cpp file that tells you, here's where you need to put your code for the following 13 functions. Okay, you're going to have to write 13 functions. You do not have to do the actual function declarations and all that. I've done a lot of that. By the way, I've also put a lot of comments in there. So this assignment should be, all things considered, relatively easy. Find the program, find the files, look in the .cpp file for the dynamic array, and start writing the specific functions. Okay? In the future, I won't be giving you as much boilerplate code. You might get a .h file, and you'll have to write the entire .cpp file. One of the criticisms from last year's class was actually you didn't let us write enough code in some of the from scratch. So you're going to get a more opportunity to do that, and you can beat up the people in last year's class if that's not good for you. You will be using the make file and the provide script, and if you don't know what that means, I'll show you in a minute what that is, to test your code and actually submit your code. Okay, you have to do that online, so it's better to keep all your files in one place online. Let me show you what that entails. Okay, if we go back here and homework 1, oops, oh, I'm in homework 1. Here's all the files. There's a make file here. Let me show you what the make file looks like. Sorry, it's small writing. If you can't see this, I'm sorry. It basically is, I'll go through more details on the slide in a minute, but it basically does all the compiling for you. Okay? All you have to do Actually, if I type make clean, that will remove any compilations I've already done. If I type make, it compiles it for you. It puts your compiler, puts some flags, tells the .o for the file, tells and actually does it for you. Wow, that's nice, right? And .hw1 or hw1 happens to be the name of the program. And if you do /.hw1, right, it will print out what the results are. This first assignment happens to be on the assignment is about a deck of cards. Like you'll be building some back-end dynamic arrays that deal with a hand and a deck of cards, right? So these are like, the printout here is like 9 of diamonds, 10 of diamonds, jack of diamonds, et cetera. It's like a deck of cards, right? So you'll see that when you read through the assignment. OK? Now, when you are satisfied that your program is complete, you have to provide it. Comp 11 people will know what that is. I've made it easier. Here's what you have to do to provide. You type make provide, and it provides it for you. I'm going to show you that in a second. For those of you who don't know what provide is, it's a program written by one of the professors here, and it takes all your code that you wrote and copies it into the grading place where we use it to grade, and it runs tests on it. And it says, hey, did this part crash, or this part worked fine, this part passed the test, et cetera. Let me show you. If I have an error in the program that I wrote here, right? And if I do provide, it says, here's all the files we're about to provide. You type yes, and it copies them all, and then it starts running the tests. And this is going to fly. Some of this is going to fly by. I'll go back up in a second. But in this case, what it's saying is, this test passed, all these tests are passing. Okay? And in this case, it ran 12 tests, and one of them happened to fail. Okay, test 2. It says test 2 main.2 cpp failed. We're going to give you the code that it failed on. We're going to say, here's what we tried to test in your program. Go ahead and include it in your program and test. Make it one of your own tests. I don't really care, right? You can do all the tests here and see them. Okay, we reserve the right to do other tests when we actually do the grading. Okay, but we will give you some when you do the provide script. And it tells you, it says, look, here's what we expected the output to be. That was this. What your output was got signal 139, which means that it had a segmentation fault. What I actually did on this was instead of counting down on some variable, I counted up. And it kept counting up forever until it crashed. That's what this did, right? So it tells you exactly how to where the problem is. Okay? That's how you use the provide script. Any questions on that? I mean, you will have lots of opportunities to practice this in labs and over the next couple weeks. Yeah? Yeah, so did you take Comp 11? Comp 11, how many times did you get to provide each program? 3? I think I'm going to let you provide 100 times. I mean, basically, you provide as much as you want. Yeah, I'm not too worried about that. I mean, if it gets to the point where it's a little ridiculous, then we'll go from there. But that's that. OK. Make files. We only have a couple minutes. I won't go through all the details here. But the make file is a script that says, here's how you do all these compiling things. You will not have to write these. I'll provide these for you for most of the assignments. Maybe you'll have to write one on the last assignment. Otherwise, I'll give you the make file. So why not? That's my thing for you. OK? Assignment 1, auto grade. We'll talk more about that later. Your tests I already talked to. If you find the assignments easy, awesome. I'm glad. If you find them easy, make them better. Do something fancy. Put it in your README and say, this is what I did to make this a better program, blah, blah, blah. Right? You're totally allowed to do that. You still have to make it pass our tests. So you can't change things enough that it fails our tests. But if you want to make it better, like if you want to have the card game figure out poker hands or whatever, fine. Right? Then do that. That's cool. You're totally welcome to do that. Did I say when this is due? Next Friday, 11:59 p.m. That is not a hard deadline. Look, I don't care if it's 1 a.m. right on Friday night. I put midnight because I want you to plan ahead and kind of be ready to go about then. But if you have a little extra to do and it's 1 a.m., fine. I don't really care. It's not good that Sunday you email me and say, oh, I didn't provide yet. No, right? You get a few hours leeway, maybe till the next morning. Don't abuse the privilege. Okay? We won't be having tokens and all that stuff. Just submit your stuff. I'll deal with anything. If you happen to have reasons that you can't hand assignments in, email me. We'll figure it out. Okay, last minute questions. Yeah. Lectures are going to be posted. They already are for today. Anything else? Yeah. You can stop by right now if you want. Or later, doesn't matter. Anything else? See you Monday.